Okay, so now I'm taking a look at the final exam from fall 2016. This is question number 1, and this is also a partial fractions question. So the question was 5 all over x minus 1, x squared plus 4. Now they were nice enough to actually give it to us in factored form already. Okay, so again, we're dealing with this x squared plus 4. So this is also an unfactorable quadratic. So you want to be really careful. This is not equal to x plus 2, x minus 2, or x plus 2 quantity squared. Make sure when you have all of those that you always FOIL them out just to make sure that you get back to where you were, and then you'll be able to see that this is an unfactorable quadratic. Okay, so like we did before, let's set this up. 5 all over x minus 1, x squared plus 4. Okay, now I've got this x minus 1. This is a factorable polynomial. This is a solution of x equals 1. So I'm going to just set that up over a single variable a, x minus 1. I have an unfactorable quadratic that allows for this special format, bx plus c, x squared plus 4. So my goal here on doing these is to solve for a, b, and c, right? Because I want to be able to integrate these pieces here, which are more straightforward than integrating this big function right there. Okay, so our first step after breaking this up is to multiply both sides by our denominator over here, squared plus 4. Okay, so what's going to happen is this becomes 5 equals, so a times the x minus 1 cancels out, and I get x squared plus 4. This is a parenthesis. Plus bx plus c. Make sure you have parentheses around the bx plus c so you don't forget, and you remember to FOIL this out, right? The x squared plus 4 is cancel, and I get x minus 1. To distribute this out, I'm going to need to FOIL this, but we're going to not get ahead of ourselves. Okay, so our next step in doing this is I've got some low-hanging fruit. This is where x is equal to 1 as a solution. Okay, so if I plug in, everywhere I see an x, I plug in a 1, right? So it doesn't matter on this side. So I'm going to get 5 equals a times 1 squared plus 4 plus b times 1 plus c. You don't even need to do this part. I'm just showing you minus 1. So this part here drops out to 0, which makes this whole thing equal to 0. So I don't have to worry about that whole term. You don't even need to do this, but I'm just showing you that this is 0. Okay. So that means this whole term goes away, and I'm just dealing with being able to solve for a. So I've got 5 equals 1 plus 4. So this is 5a. Divide both sides by 5, I get 1 equals a. I'm going to put a box around it. Okay. So now I've got that. Now let's plug it back in. We're dealing here. Okay, so I've got 5 equals 1. Right, I'm substituting in 1 for a. I just solved it. X squared plus 4 plus bx plus c, x minus 1. Okay. Now, because we're dealing with an unfactorable quadratic, what I need to do is FOIL this out and start grouping things by coefficients of the terms x squared and x and the constant terms. Okay, so if I multiply out the 1 times this, I'm just going to get x squared plus 4 plus, if I FOIL this out, I'm going to get b x squared minus bx plus cx minus c. And all of that is equal to 5. Now that 5, right, if you think about that 5 equation, there's a 0 x squared plus a 0x plus 5. Okay, so in terms of grouping by coefficients, keep those in mind, that we have zeros times the x squared and the x terms over here. Okay, but first let's group our terms together. So I've got an x squared. I have what's left over is 1 plus b, so I've got this one and this one, plus x. And what I have is minus b plus c, or I'm going to write it as c minus b. And then I've got my constant terms. I've got a 4 and a c. I'm going to group those constant terms together. And that's all equal to 5. Okay, so now let's take it apart. And I'm going to group, I'm going to set the coefficients equal to each other. So if I've got a 0 x squared, I've got 0 equals 1 plus b. Right? My second simultaneous equation is 0 from this side equals c minus b, right? So this is the coefficient over here. This is a 0 x squared plus 0x plus 5. So this 0 goes here, this 0 goes here, okay? C minus b, and then our last term, our constant terms are set equal to each other, 1 minus c, okay? Now we have 3 equations and 2 unknowns, so it should be pretty straightforward. So I'm going to subtract 1 from both sides here. So I'm going to get minus 1 equals b. I'm going to put a little bracket around that. Okay, I can solve for c right here. I'm going to get minus 4, minus 4. All right, we can also do it here too, but I'll just show you. It should come up to be the same. So this is 1 equals minus c, c equals minus 1. Here says b equals c, right? So b equals c, so these equations confirm each other. It's a good cross-check just to make sure that you're doing the algebra correctly. Okay, so that was all set up so that we can do our integration. So let's set up our integral. So this was all to be able to do 5 over x minus 1, x squared plus 4, dx equals, let's put the things together from our original a over, right, bx plus c. So it's going to be the integral of a, 1 all over x minus 1 dx plus bx plus c. So minus x minus 1, right, because minus 1 equals b, minus 1 equals c, all over x squared plus 4 dx. Okay. Now when I go to integrate these, okay, so this one here, okay, I've got a 1 over. Okay, if I can think about u substitution, if I thought about u substitution, what I'm going to get is 1 over u. So I'm going to get a natural log. Oops, natural log of this whole thing, x minus 1. Okay, I don't have my coefficient, it's just 1, so it's going to keep that. Now what I have is, I've got this minus x minus 1 all over x squared plus 4. So what I'm going to do is I'm going to break this apart into 2 pieces. I've got a denominator, I'm going to 2 pieces there. So plus minus x all over x squared plus 4 dx minus 1 all over x squared plus 4 dx. Okay, so 2 different types of integration that we need to work our way through. Okay, so this one here, we'll do this one first. And I can even take this negative 1 out. So let's do that. It becomes negative, and this is a positive here. So u, I'm going to do u substitution because I've got an x squared plus 4, and I've got an x in my numerator. So my u is x squared plus 4. My du is equal to 2x dx. So I just have an x dx, so I'm going to divide both things here. So now what I'm going to get is, I'm going to get 1 all over u times du all over 2. So I can factor out that 1/2 natural log of u. Okay, so now I'm going to substitute back in. So I'm going to get 1/2 natural log of, my u is x squared plus 4. And then don't forget we were subtracting that. So I'm going to put that negative down here. Okay, this one here, okay, is a trig substitution. Right, this x squared plus 4, we've been thinking about things in terms of x squared plus 1, but it could be x squared plus a squared. Okay, and when we do the x squared plus a squared, let's write this off to the top here. So if I've got this 1 over x squared plus a squared dx, this is an inverse trig, inverse tangent. Now what happens is this becomes 1 over a, x over a, okay, is our integral for that, right? So now our a here, our a is equal to 2, okay? So this becomes minus 1 over 2 inverse tangent of x over 2. Okay, and then I'm going to add in the plus c so I don't forget. So let's put it all together because I've got this bit here I need to add in. So I'm going to get the natural log, don't forget the absolute value is minus 1, minus 1/2 natural log absolute value x squared plus 4, minus 1/2 inverse tangent x over 2, and then plus c. Don't forget your plus c because we're doing this partial fractions, okay, on an indefinite integral.